Algebras. Welcome to your Chapter 11, Lesson 1 through 4 quiz review. So let's go over the things that we've been talking about in Chapter 11 so far. First thing we did was we talked about the properties that our parabolas have. So how there's an axis of symmetry and a vertex on that axis of symmetry, how there are roots where it touches or crosses the x-axis, how that vertex is either a top point or a bottom point, which we call a maximum or a minimum, and how based on the x always going from negative infinity to positive infinity or increasing, what is the y doing based on that, right? So let's take a peek at those particular things. We'll label them on the graph and then we'll state them next to it where it lists these things, right? So the axis of symmetry is the vertical line that cuts your parabola in half. So I kind of sketch one out and then I label it AOS for axis of symmetry, which is x equals -2. Since your axis of symmetry is a line, it has to have an equation. You can't just state -2. That's not right. That's not a thing. You won't get credit for it. It's x equals -2 because it's the vertical line that's cutting your parabola in half. On that line is your vertex, which is also known as your turning point. That's where your parabola turns back around. It's always the point of the parabola that's on that line. So this point, of course, the vertex here is -2, always the same x value as the axis of symmetry. And let's see, 1, 2, 3, +4. So -2, +4. That is a coordinate point. So an x and a y coordinate in parentheses and comma between them. The roots are the 2 points or 1 point or no points that touch across the x-axis. So right here and right here, I am crossing the x-axis. And the roots are either listed as just your x values or they're listed as the coordinate points where we're touching and crossing the x-axis. Now, we listed the roots this way in chapter 8 and 10, so that's why I want to just make sure you understand when we were solving quadratic equations, we were finding the roots. We were finding where they touched or crossed the x-axis. Those, of course, are at points where the y value is 0. So when you're matching y value is 0, those x values indicate the roots for that parabola. This vertex is a top, so it's a maximum, and you can just circle. The domain where this is increasing, it means the y values are increasing. This always has to do with the axis of symmetry. The x value of the axis of symmetry is what this is based off of. So look at the axis of symmetry and look for the place where the y values are getting bigger. And so on this side, all the y values get bigger up until here. Those x values are all smaller than -2. So the domain where this function is increasing is x is less than or equal to -2. So those are all the pieces. See, this is increasing. Y is getting bigger, Y is getting bigger, Y is getting bigger until they get to the max and then turn back around. All right. Next thing we did was found these pieces algebraically. Okay, so we need to find these pieces algebraically. We use the x equals -b/2a or axis of symmetry formula, which is the front and bottom of the quadratic formula from chapter 10. We use those to plug in and find the axis of symmetry. So the negative of -6 divided by 2 times 2. Oh, so it looks like this one is going to be a fraction. So I'll just put it in simplest form. 6 and 4 both even. So the axis of symmetry here is x equals 3/2. I can tell that this is a minimum because this is a positive a value. So the a value is positive. That's a smiley face parabola that has a bottom or a minimum. If the a value is negative, that's a frowny face parabola that has a top, that's a maximum. So that's how you can tell just from looking at the equation. Let me just pop back over to number 2, where we are now going to plug back in. Oh, it's f of x, my bad. not a y equals equation. It's an f of x. So we're going to do f of 3/2 or 1.5. All right, and I'm just going to replace it everywhere. So 2 times 3 over 2 squared minus 6 times 3 over 2 plus 7. All right. Oh, graphing calculator on screen. How about we use that guy? Otherwise, he's just sitting there. We don't want to let him just sit there. Let's plug that in. 2 times 1.5 squared minus 6 times 1.5 and then plus 7 gives us what? 2.5. Let's do that as a fraction. Math. Enter, enter. Turn that into 5/2. So f of 3/2 equals 5/2. That's a point, of course, a vertex. So it's 3/2, comma 5/2. Usually integers, but of course we know we can get fractional or decimal answers for those as well. We've seen that a few times. So let's try this over here again. This time, x equals negative b over 2a. We actually have an a value other than 1 to plug in there. That's nice. Negative of 6 divided by 2 times negative 1. I get negative 6 over negative 2, which is an x value of 3. So my axis of symmetry is x equals 3. Now I plug that back into y equals negative 3 squared plus 6 times 3 minus 9. And I can just plug that straight into my graphing calculator again. Oops. Because I made my graphing calculator big, you didn't see what I just wrote. And that's all I'm going to copy right in here. So negative 3 squared plus 3 times 3 minus 9, negative 9. So the point 3, negative 9 is my vertex. There we go. Algebraically. Looking good. So far, so good. All right. Then we were graphing. If we're given something like negative 4 is less than or equal to x, which is less than or equal to 2, this is what we call a domain limit. And that is telling us to only graph this from negative 4 to positive 2. That's it. Don't graph anything outside of the domain limit. So do not put arrows on this graph and do not continue it, even if it can continue. That's information from chapter 3. So what we're going to do is we're going to use our graphing calculator to get these points. Press y equals, I wonder if I have stuff in there. No, not yet. Okay. Negative, so it's this guy under here, x squared minus 2x plus 3. Press graph to see it. Frowning face parabola, but I knew that because it was a negative x squared, right? I can see my roots at 1 and negative 3. I can see my axis of symmetry at x equals negative 1. Let's get those points, though. You can see my y-intercept at 0, 3. All right. Well, I'm not going to graph 7, negative 60, so let's kind of move this around so we can see points I can graph, starting with negative 4, negative 5, which, of course, is the beginning of my domain anyway. And the end of my domain goes to 2. So those are the lowest points, right, that I will fit on this graph because those are my limits. We see, of course, that the highest point, the maximum or vertex right here, is here in the middle, right? And then you've got each side. And then, of course, you've got the roots where y is 0. Those are the roots where we touch across the x-axis. Here's our y-intercept, which is the only point where x is 0. And, of course, x equals negative 1 is our axis of symmetry. So we can see from our table all those key pieces that on the graph will make our parabola what it is. 1, 2, 3, 4. Positive 4, right? Because our y-intercept is positive 3 right here. And then our roots are 1 and negative 3. I'll back up a sec. And then, of course, I can go all the way over to negative 4, negative 5. And that's where I have to stop. No arrows. Connect, but no arrows. State the zeros. That would be negative 3 and 1, which of course you can state in the French curly braces, like in chapter 8 and chapter 10, or you can state as points. Okay, because those are the points on that particular parabola. Write the equation of the axis of symmetry. Sure, no problem. We already know that that's x equals negative 1, so I'll just write it down. I had it labeled right there anyway, right? You can see it right here. I mentioned it when I looked at my graph on the graphing calculator. Over what interval is our function decreasing? So this side of the x-axis is the decreasing side, right? That's the decreasing side. So what side of the x-axis are we on? We're on, or excuse me, the axis of symmetry. We're on the upper side, the side that are the points that are greater than negative 1. So x is greater than or equal to negative 1 would be our decreasing interval for this particular parabola. Remember, no arrows on the end when you're given a domain limit, and that's back from chapter 3. We learned it back then. So this particular parabola, we want to know when it's greater than 0. So here's where it's greater than 0 on either of these sides. So it's two separate sides. It's not a continuous place that this parabola is greater than 0. This is all between negative 1 and 3, that it's smaller than 0. But this side is x values greater than or equal to 3. And this side is x values less than or equal to negative 1. So we want an or situation here when our parabola is actually greater than 0. So all those x and matching y points are greater than 0. Then, of course, we're given a table and we have to figure out what's not a valid conclusion. So you want to make sure you read it carefully. 3 choices will be valid, 1 will not be. So when it comes to something like this, be very careful, right? So the rocket was launched from a height of 40 feet. Yup, because 0, 40. So we started out 40 feet high. The maximum height of the rocket occurred 2 seconds after launch. Well, between 2 and 2.5 seconds is my maximum, right? So I'm not sure about this. I can't really check it yet. The rocket was in the air approximately 5 seconds before hitting the ground. Absolutely. That is definitely true. The rocket was above 96 feet for approximately 2.5 seconds. Above 96 to above 96, that's 2.5 seconds. So look, the one that I was, I'm not sure, don't really think so, was thinking, no, that's probably not true. Not true, right? That's the one not valid conclusion. Well, look at that. If a punter kicks a football in practice, it looks like a parabola. Huh. It's almost like math writes the world for us. Almost like that's exactly how it goes, right? Let's plug this sucker in. Negative 16x squared plus 48x. So there's the equation for the path of the football as the punter is kicking the ball in practice. Where x is the number of seconds after the ball is kicked, h is the height. Oh, because it's h of x. Got it. Yep. All right. Based on the graph, what are the zeros of the function? Oh, all right. I didn't even press graph yet. Let's look. Oh, yeah. That's going to be too big of numbers for me to look at here. So let's press second and graph and see a table. Now, we're not going to look at these points that have negative x values because, well, we're not going to have negative time, right? So that's not going to do anything for us. But also, we can't look at those negative y values because we're not going to have negative height either. We're talking about ground up and time starting at 0. So 0, 0 is where I start for this table, which I have a little space for over here. Why don't I, you know what? Let's go by half seconds. So let's change this so we can see what we're doing at the halfway points, right? So second and window goes to our table set. And I'm going to change my table start to 0 because that's where I want to start. But go down, arrow down to delta table and change it to 0.5. I want to go by halves. All right. Because I want to see what's happening at the half second. So after half a second, then 1.5 seconds, then 2 seconds, then 2.5 seconds, and so on. So I think I'll get a little more information about the graph that way. All right, so here we are, 0, 0, and 0.5, 20. So 20 feet in the air, we're saying. After 1 second, we're 32 feet in the air. 1.5 seconds, 36 feet. 2 seconds, back down to 32. Oh, that was my axis of symmetry and turning point. Okay. Well, that makes a lot more sense. I'm glad we went by half seconds because otherwise we wouldn't have seen that, right? We wouldn't have seen the maximum height of the ball and how long it took us to get there. So what we're saying is the ball was only off the ground for 3 seconds, right? Because at 0 time down to 3 time, those are our zeros for the ground level, right? That's ground level. So I'm going to actually answer the questions first and then do the graph because you can answer all the questions based on the table. And that's what I want to make sure you can see, right? So based on the graph, what are the zeros of this function? 0 and 3. What do the zeros represent? The zeros represent the times the ball is on ground level. Full sentence, please. How long before the ball reaches its highest point? Gosh, good thing we went by 0.5s, right? Otherwise, we wouldn't have known the answer to this question. And it's 1.5 seconds. What's the maximum height? We wouldn't have known this if we hadn't gone by 0.5. See how it was a really good thing we knew how to do that? 36 feet in the air. And how long before the ball reaches the ground? We had 3 total seconds from kick to ground again. So now what I'm going to do is looking at this graph, my quadrant 1 graph, I'm going to, well, this will be easy down here because I can just go by 0.5, 0, 0.51, and then 1.5, and then 2, and then 2.5, and then 3 is where we're back on the ground, right? So we know these points right here. But going up the y's, I got to fit from 0 all the way up to 36. So let's see what we can go by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can go by 3s, right? And that'll get me to 36 at the very top. Starting with 0 down here, right? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33, and 36. So 0, 0, 3, 0, we got those just fine. Now 0.5 all the way up to 20, so we're a little closer to 21 than 18. 1 all the way up to 32, well, a little below 33. 1.5 right up there at 36, and then follow back down, right? Down. There's the football on the graph. So we just put actual grid lines to the picture above. And there you go. Let me label. This is height. I know my table came a little close, so sorry about that. I'm a little close on my table on that guy. But that's it. That's what you're looking at. And that's what we've learned so far in chapter 11. Now, of course, your quiz is in Delta Math, but you still need to make sure you do this particular assignment. So I see you algebraically using your axis of symmetry formula, x equals negative b over 2a. Okay? All right, guys, good luck. Let me know if you need anything. And we'll be doing that Delta Math review and or quiz together in class, so you'll be ready to go for yours. I'll see you soon.